Hello, this is Saraj Jain. Today we will discuss about the full wave bridge rectifier. Before that, we discussed half wave rectifier and center tap full wave rectifier. So this is the full wave rectifier, but having different configuration. It has a bridge. So in bridge there are 4 arms. Each arm has one diode. You can see from the circuit diagram. Transformer is there. However, the need of transformer that required in the full wave rectifier center tap is different, as in center tap full wave rectifier we had a transformer with center tapping, but it is not required in this case. A simple transformer can be used. This one is the transformer having primary winding. Input is connected to the primary, having secondary winding. One bridge is there and load resistance is there. So again, due to the nature of the AC input, there are two half cycles, that is positive half cycle and negative half cycle. For the positive half cycle, what happens, let us see. During the positive half cycle, this end of the secondary becomes to be positive and this end becomes to be negative. Due to the positive polarity of this end, the only possibility to get the forward biasing of the diode for diode D3, because a node of diode D3 is connected to this positive end. So diode D3 becomes to be forward bias, this diode D2 becomes to be reverse bias. Due to the negative polarity at this end, the only possibility to get the forward bias for the diode is D1 and diode D4 becomes to be reverse bias. So we can say two diodes are forward bias simultaneously and two diodes are reverse bias simultaneously. So for the positive half cycles, diode D3 and D1 will start to conduct and diode D2 and D4 does not conduct. However, the current flow from transformer is secondary upper winding through diode D3, load resistance through diode D1 and back to the lower end of the secondary. So current start to flow through the load. We are getting the output current as well as the output voltage. However, the two diodes are in series, so both diodes are responsible for supplying the current. What happens in the negative half cycle? Let us see. During negative half cycle, this is a picture showing the two diodes D1 and D3 during the positive half cycle becomes to be forward bias, so they acts or allows the flow of current through them, so they can be represented through short circuit, as short circuit is there in the arms D3 and D4, while diode D2 and D4 becomes to be reverse bias, they act as an open circuit. This is the equivalent bridge rectifier circuit diagram during positive half cycle. However, what happens in the negative half cycle? Let us see. During the negative half cycle, for the input voltage, we get the negative voltage here and positive voltage here. Due to the positive voltage at this end, the diode D4, and due to the negative voltage at this end, the diode D2 becomes to be forward bias. So the diodes which were reverse bias during the positive half cycle now becomes to be forward bias, and the diode which was forward bias during the positive half cycle now becomes to be reverse bias. However, the current will flow from here to diode D4 through load resistance and through diode D2 back to the transformer's upper end. However, the two diodes D2 and D4 now conducts and D1 D3 does not conduct, and the equivalent circuit diagram for this circuit may be like that. Two diodes will conduct. Simplified circuit is there. So we are getting the output voltage for both polarity of input voltage, since this is a full wave rectifier. However, the difference between the center tap and the bridge rectifier is that center tap transformer was used in case of the center tap full wave rectifier and two diodes were used. However, here there is a no need to use a Santa tapping. We can use the simple transformer. One more difference is that it uses 4 diodes in form of bridge. So in order to get the smooth output, ripple free output, again we will use some form of filter. Here, as we already use capacitor filter, again we'll use a capacitor filter. This is a capacitor filter for getting the ripple free output across the load resistance. So whenever the 2 diodes in the forward biased will conduct, the capacitor will charge. However, the capacitor will charge up to a peak value of the input voltage. During the negative half cycle, when the load voltage becomes to be start to decrease, the capacitor will start to discharge and will supply the current like that, as we have seen in the previous sections. So this capacitor now will smooth the DC output. Previously we are getting the output like this, ripples was there, so ripple factor was more. However, when we use the capacitor filter, and the output converts from having ripples to this form, so it is very less variations are there, so we are getting the smooth output. Thank you.